assuming everything is real. Real numbers. Yes, I agree with that. But not when it's a sum or a difference. This is carved in stone. But always remember, when we are asked to find the domain of this function, that's what we are asked to find domain. We're not asked to simplify, we're not asked to touch the function. We have to write a condition, we have to solve the condition, and then get the domain. We're not simplifying the function.
That means that we have to change the x for another number?
No. No, let's take a look at what we just wrote here. So the square root function exists only if I take the square root from positive or 0. Now, what am I taking the square root from here? Can anyone read that to us? What am I taking the square root from this function?
4.
No. We're not taking the square root from 4. We just mentioned we cannot simplify.
We're taking the square root of 4 plus 5.
Exactly. We are taking the square root from 4 plus 5x. Not from 4 and not from 5x. We're taking the square root from 4 plus 5x. Awesome. What does this condition say that 4 plus 5x should be? This tells us what the condition is. How do I write something like that?
Is it equal to 0?
That's one piece, but it says this or this, not just this.
Greater than or equal to 0.
Brilliant, thank you so much. That's all I needed. I will move forward to the other side. Oh, that's what I said, and that's what I'm not doing. And I will divide by 5, everybody knows that. That will give us the domain. Can anyone tell us what to write in interval notation? Again, Sissy, I haven't heard from you. Jack, I haven't heard from you. So I'm assuming you're not here. Mercy, I haven't heard from you. Anyone?
Would it be negative 4 to infinity?
Yes, indeed. Negative 4/5 to infinity. That's it. Brilliant. Thank you. Thank you, Amar. Good. That's it. So now when we look at that more sophisticated one that you picked, which was 54. So h of x equals the square root of 2x plus 3 minus the square root of 12 minus 5x. We're mimicking the same thing. We have the exact same steps. Can anyone quickly tell us what to write? For this one first.
Would it be 2x plus 3 greater or equal to 0?
That's it. For this one now.
12 minus 5x will be less than or equal to 0.
So let's go back.
Oh. So when you said even or odd, you mean the square number? Oh, okay.
Anyone?
Greater or equal to 0?
Excellent. That's it. I have to solve this like we just did for that. 2x greater or equal to negative 3 and divide by 2. Leave it alone for a moment. The same thing here. Move 12 to the other side. Or subtract whatever you want to write. Negative 5x greater or equal to negative 12. Now I'm dividing both sides by negative 5. So I get x here and 12/5 here. Anything specific or special happens right now?
You would flip the sign.
Brilliant. Thank you so much. When we divide by a negative number or multiply by a negative number, we have to flip the sign. So leave it alone for a moment, because these two conditions have to exist at the same time for h of x to exist. Here's what we are going to do in this case. But again, this is a more sophisticated example. This is the real line or number line. 0 is somewhere in the middle. And here's what I'm going to do next. Greater than or equal to -3/2. So it's somewhere here. I don't care for units. So this is a number, -3/2, and greater than or equal to. I will use a different color for less than or equal to 12/5. This is 2 point something. I don't care. It's right here. I don't care for units. I'm using this just to identify what I need. But this is less than. We have to pick that piece from the real line where both colors exist, because both radicals have to exist at the same time for this function to exist. So again, notice we haven't tried to simplify anything. We are only trying to say what has to happen for this to exist. This has to happen. What has to happen for this to exist? This has to happen. Then I perform my calculations on simple linear inequalities, and I just came up with two conditions. This one that says to the right of -3/2, and this one that says to the left of 12/5. Which territory from here will be the domain of h of x? Not of the first piece, not of the second piece, but of them together at the same time.
-3/2 to 12/5.
Exactly where they both exist. Here one of them exists, but not the other. Here the other one exists, but not the first one. So this is the domain. Very good. Indeed. -3/2, comma, 12/5. Good. I would like to look now. Any questions for me, please? Any questions? I would like to look now at some rational functions, and then we can move on. Okay. So please choose. I don't know, 33, 43, 51, 52, 49.
51.
51. Okay, where is 51? Perfect. And 51, we have g of x equals 1 over x squared plus 9. And I will also pick 43 together. We're going to discuss both. 3x minus 1 divided by 7 minus 2x. As you know, we have, as I mentioned, many different functions, many. So this is just 3 examples. We have here 3 examples. This one is very friendly, no problem. This one we identify it now. If it has index 3, no restriction, nothing. Friendly means everything. But now we have a situation in which we have a rational function. I know what can go wrong here. For this to be negative, that's a tragedy. But what can go wrong here? And I'm going to write that function too. 2x over x minus 3. What can go wrong with a rational function? That is not allowed.
It equals 0.
Say it again, Sam.
The denominator can't equal 0.
Excellent. Denominator can never equal 0. I'm not saying x. I'm saying the denominator. Awesome. Brilliant. Thank you. The denominator cannot be 0. If the denominator is 0, so for example, if I have 5 divided by 0, how do we call this? There is a special name. It's a fancy name that we like.
Undefined.
Thank you. Brilliant. Thank you so much. Undefined. So we cannot have 0 in the denominator. But I want to caution you on something that we are going to move on to when we go to chapter 1. 0 over 0 is not undefined. It's called indeterminate. Okay? So that is a different situation. We will get to it in chapter 1. But a number not 0, any number not 0, divided by 0 is undefined. So this is the problem with this function, with this function, and with this function, potentially. So let's start with the first one. What condition do I have to write and solve? I have to write a condition, solve it, like we just did with the radical, and find domain. These are the steps. I want the condition, then I solve it, and then I find the domain. For the first one, can anyone give us the condition that I have to write?
X squared cannot equal -9.
Excellent. But we normally have, perfect, brilliant. But I have to write it like this first. This is the condition, and then I will solve it. Perfect. Oh, perfect. What type of number, these are my props, as you know. What type of number is x squared? Always and forever.
Positive numbers.
Excellent. Brilliant. Then I'm adding a positive number. So when I add a positive to a positive, what is the answer?
Positive.
Always. Can this be 0?
Nope.
No. So then, this is nice. This function, it happens that it has domain, all real numbers. No problem. Friendly. Good. Moving on to the next one. Condition, solve it, domain. Condition. Please.
-2x.
No, I want the
7.
condition. I don't want it solve it. I want everyone to see the condition. You're way ahead of me. I love it. But I need everyone to see the condition, and then we solve it.
Would it be 7 minus 2x cannot equal 0?
Of course. I move 7 to the other side, changing its sign. And I divide both sides by -2. How do I write the domain of 43? How do I write everything except x equals 7/2 in interval notation?
Would it be open parentheses -infinity to 7.5 close parentheses?
I cannot. If I close it, I include it. If I close it, I include it. I cannot include it. It has to be open.
And then union.
Excellent. Open again.
7.
Yes.
7/2.
Exactly. This is the same thing. This is the same thing said in two different ways. Everything except x equals 2 is the same with domain. Everything till 72, not 7/2, I meant to say. Union, not 7/2 to infinity. Awesome. Good. Final one. Condition, solve it, domain. Can anyone else tell us what to write? Please.
X minus 3 cannot equal 0.
Excellent. That's the condition. Brilliant. Indeed, x minus 3 cannot equal 0. I move 3 to the other side. X cannot equal 3. And now the same thing, everything except 3. How do I write it in interval notation?
-infinity, comma, open parenthesis, -infinity, comma, 3, closure parenthesis, union, 3, comma, infinity.
Excellent. That's it. Good. So if we want to read, for example, from this graph, can anyone give us the domain of this function? The domain.
If it's a solid dot, that means it's
Correct.
including.
Bracket. Yes.
So it would be a parenthesis.
No, you just said that. So it's a bracket.
No, I said if it's an open circle.
Oh, yes, yes, yes. If you remember, we had that. It took me a couple of minutes to print it out. But we had that situation, right? If I did not have, if this piece were not there, I would have said the domain is between -2 with an open parenthesis till 4. If we did not have this piece, correct. Good. So it's between -1. Yes, and
-1.
And somewhere between 2 and 3.
2.5.
Yeah, 2.5. Excellent. And what about the range?
-8
to
3.
Excellent. What if I ask what is the x-intercept or x-intercepts? What would you say? X equals 0 and
2.
And 2. What about the y-intercept? And you can never give more than 1 because it will not be a function. Yes, 0 again. Awesome. Okay, I think we have this down. Would you agree?
Agree.
Okay.
Yes, ma'am.
Okay. Let me know at any point in time if you need more examples. I'll be more than happy. Maybe we want to look at 63, whatever. Use the graph to estimate the domain and use the graph to estimate the range. So what will you say from
Close parentheses, 25
Yes.
to 100.
Yes, and the range?
From 0 up to, I can't tell that. Looks like a 450.
450. Excellent. Okay, so now we can continue. I know we have 10 more minutes, but I'd like to continue. The next section should give us 0 difficulties because it's all about slopes and we already talked about it. And I need page 44. And enter. Awesome. It makes me very proud when you participate, even if you say, I don't know, because I know what to correct. We already determined and graphed something like this. So let's move on directly to, let's refresh our memory, first of all, on the list of, so this is already R.4. And I should have put the title here so I don't confuse you. Let me do just that. So here it was R.3, domain and range. And maybe even from the previous page, from here, actually. Okay. And now we are looking at R.4, basically lines. We already looked at the slope, and you already told me rise over run. And you said y2 minus y1 over x2 minus x1. We have 2 equations of the line. So also let me give you all possibilities for lines. This one is an increasing, so the slope is positive. This one is decreasing, so the slope is negative. This one is horizontal line. What is the slope of a horizontal line? Easy or difficult to work on it?
Wouldn't it be 0?
Yes, awesome. What about how many people can walk on this line? What is the slope of this line, which is vertical?
90.
Say it again.
90 degree?
Good point, but we're talking about a number, not degrees. That's okay. That's okay.
Is it 1?
Would it be 0?
Undefined.
Thank you. Not possible. Because it's the same x. x2 minus x1 will be the same, so the denominator will be 0. And the number over 0 is undefined. So the slope of a vertical line is not possible if you want to say, or you say it's undefined.